Okay, if 100 grams of O2 is reacted with 50 grams of H2, how much water is produced? We know this is a limiting reactants problem because we are given two givens from two different reactants. So first things first, the first step is to always come up with a chemical equation and then balance it. So we're adding H2 to O2 and getting H2O. I'll balance the equation to make sure that we have our mole ratios. So the mole ratio is 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. Let's do our BCA chart. Remember, B stands for before, C stands for change, A stands for after. 100.0 grams. Remember to change grams to moles. When you're changing grams to moles, we divide by the molar mass. So you can write it out every time if you want to, but if you want to skip the step, let's remind ourselves why we're dividing. Because grams needs to cancel, and we're changing it to moles. And you see that puts the mass on the bottom. So in my calculator, I'm dividing to change grams to moles, and I get 3.125 moles of oxygen. I'm not going to put moles in the BCA chart because it's going to get a little messy, and I know that in order to be in the BCA chart, my values all have to be in moles. So now let's change 50 grams of hydrogen to moles of hydrogen by dividing. So I can just say, I'm going to put in my calculator 50.0 divided by 2.016. And I pick these numbers on purpose so that you guys can see that even though I have less hydrogen, hydrogen's not the limiting reactant. So don't make the mistake of thinking that the substance present in the smallest quantity is always the limiting reactant. Before the reaction starts, I have 0 water. So these will go down, the amount of reactants will go down, and the amount of products will go up. Coefficients from the balanced chemical equation, and then X. Remember, if there's no coefficient, it's 1 understood. So now I have to figure out which one is the limiting reactant. Well, let's analyze this. I need twice as much hydrogen. So if I was going to use up all of this oxygen, I would need 6.250 moles of hydrogen. Do I have 6.25 moles of hydrogen? The answer is yes. So I say, oh, I have plenty of hydrogen. Plenty leads my brain to thinking excess, and oxygen is going to be my limiting reactant. So my equation becomes 3.125 minus X equals 0. So the value of X is 3.125, and that's moles. So now I can replace X with the actual value of X, which is 3.125. And that gives me the answers to all the questions I might have. So I produce 6.250 moles of water. And in my calculator, I would do 24.8 minus 6.250. So this is the calculation that confuses everybody the most. I don't remember what it is. It's 18 point something. So let's review what happened here. I put 100.0 grams of oxygen in a container with 50.0 grams of hydrogen and allowed them to start reacting. After the reaction was over, oxygen was all used up. The reaction stopped once I ran out of oxygen. I had leftover hydrogen. So in my container, when everything is said and done, I will have 18.55 moles of hydrogen and 6.25 moles of water. Now, to turn this back from moles to grams, remember that we multiply. So I'm going to multiply 18.55 times the molar mass of hydrogen to get 37.4 grams of hydrogen left over. And then I'm going to multiply this by the molar mass of water. So it'll be 6.250 times 18.016. And I get 113 grams of water. So I started with 100 grams of oxygen and 50 grams of hydrogen, and I ended with 37.4 grams of hydrogen and 113 grams of water. That's how we do limiting reactants BCA charts. Now, I want you to take a second and recognize that if you try to do these problems without a BCA chart, it's really challenging. So we're going to try to stick with our BCA charts until we understand them. So if you get to college chemistry, or if you decide to take AP chemistry, we're going to be using BCA charts and versions of them throughout the entire year. So for those of you who think, oh, I'll never take chemistry again, just know that a lot of, even if you're not majoring in science, a lot of majors are going to require you to take chemistry anyway. Okay, any questions? In a container, 39.6 grams of CH4, which is called methane, are reacted with 78.4 grams of oxygen. How much of each product will we get? This is a reaction you guys do every single day. And now you know enough to recognize this. So think about all the years that people go around and not really know what's going on around them. The more you learn about what's going on around you, the more interesting everything becomes. So this is the main component of natural gas. This is what you use to heat your house. This is what you use to cook on your stove, to dry your clothes in your dryer, to heat the water for you to take a shower, all sorts of stuff. So if I add CH4 to oxygen, can anybody tell me what my products are? CO2 and H2O. You get the gold star for the day. Very good. So take a second and recognize the fact, if you know what's going to happen when you put two compounds together, how powerful that is. So let's first balance this. We're going to put a 2 here and a 2 here, and we're all balanced. Now, remember, to change grams to moles, we divide by the molar mass. So you take 39.6 and divide it by 16.042, and I will get 2.469 moles of methane. Oxygen's also given to us in grams, so we're going to say 78.4 grams divided by 32 grams per mole for oxygen gives us 2.45 moles. Before the reaction starts, we have no products. So this one's a little trickier because look at how close those numbers are. But you're going to rely on the mole ratio. We need twice as much oxygen. Do we have twice as much oxygen? No. So you're going to say, I don't have twice as much oxygen. When you say I don't have enough, I want you to think limiting reactants. Because I don't have enough oxygen, that's going to be the limiting reactant. So this is minus x minus 2x plus X plus 2X. Oxygen is the limiting reactant, so we're going to say 0. My problem is right here now. So the problem becomes 2.450 minus 2x equals 0. So x in this case is going to be 1.225 moles. That's going to be the value of x. So for CH4, 2.469 minus the value of x, which is 1.225, gives us leftover 1.244 moles. CO2 is 0 plus x, so we're going to produce 1.225 moles of CO2, and water is 2x, so it's 2.450 moles. So with one BCA chart, we have the answers to all the questions we could possibly ask about this. So we started the reaction with only CH4 and oxygen. When the reaction ends, I have leftover CH4, no oxygen left, and I've produced carbon dioxide and water. In order to change these to grams, I would multiply by the molar mass. So the molar mass is going to give us 16.042. 1.244 grams of CH4 Let's circle what we have left over. $53.9 grams of CO2 and then we'll multiply this by the molar mass of water. To get 44.1 grams of H2O. So those are the answers to all the questions you should possibly ask. We started with a container that had 39.6 grams of methane and 78.4 grams of oxygen, and we ended up with a container that contained 1.244 grams of methane, 53.9 grams of carbon dioxide, and 44.1 grams of water. All right, how do we feel now?